we are moving in a direction now that we've solved equations into solving inequalities, but before we start solving inequalities, we're going to look at the graphing them and interpreting their graphs, because oftentimes when we solve an inequality, part of our solution is going to be the graph. So when we graph an inequality with a single variable, we are going to graph it on a number line. We will always read the variable first when determining which side to shade. We're going to use a less than or a greater than. We're going to use an open circle to symbolize that we can't actually be that value. We can get infinitely close to it, but we can never actually be that value. It's not included in our solution. And we're going to use a closed circle with greater than or equal to or less than or equal to show that we can include that value. So before I start, we just have a bunch of examples. I am going to edit example 3. So I want it to say, I want it to look like this. So if you have a notes template, if you could change that, or if you are taking your own notes, once you get to example 3, just make sure to use this as your example as opposed to what I had there originally. Jumping into my examples, according to this, I'm going to graph it on a number line. So first thing I do is I make a number line. Because I'm comparing x, or I'm discussing x in relation to 6, I'm going to put 6 on my number line. I do not have to draw a big in-depth number line starting at 0. From here, I then ask myself, am I going to use an open circle or am I going to use a closed circle? Well, because there is no line under my inequality, I'm going to use an open circle at 6. And then I have to determine, am I going to shade to the left, values that are less than 6, or to the right, values that are greater than 6? Well, reading the variable first, I'm going to shade values x less than 6. So I'm less than 6 to the left. So I shade that side of my inequality. Example 2, I'm going to go through the same thing. I do my number line. I'm going to go ahead and label -2 since that's the value that x is being compared to. And not make a full number line, but I am going to add a couple extra values. I always want to have more than one value. And I'm told that open circle or closed circle, because of the line underneath, I'm told that I'm going to put a closed circle at -2. And then reading my variable first. So in English, we always read left to right. In math, we read according to order of operations often, or in this case, in terms of the variable read first. So x, it's pointing at it, so x is less than or equal to -2. So I'm going to shade the side of -2 that is less than -2. Well, values are less than -2 on the left side, so I shade the left. Moving on to example 3. Example 3 is what we call a compound inequality, meaning that I have either a variable in between two numbers, or I have two separate inequalities to graph or solve. Well, so graphing these, I'm going to use my number line. And again, I do not have to write out all my values. I'm going to go ahead and put -3 and 5 on my number line. And then I'm going to do each inequality individually. So I'll look at this one first. And I need to have an open circle, it looks like at -3. And then reading the variable first, x is less than -3. So values are less than -3 to the left. So I shade to the left. It looks like I want a closed circle at 5. And x is greater than or equal to 5, so greater than is to the right. So I shade to the right. And that's going to be my or situation. I had a previous students once say they always remembered that oars looked like they were two oars coming off the boat. So if that helps you remember what an or situation should look like, go ahead and use that. Number 4, this is what we consider to be an and situation. X has to be in between -4 and 3. It's still a compound inequality, so I'm going to graph it in the same manner. I'm going to make sure both -4 and 3 are on my graph. And I'm going to do each piece individually. So looking here first, it looks like I need a closed circle at -4. And reading the variable first, I read x is greater than or equal to -4. So I want to shade to the right. Doing the same thing with 3. I'm going to go ahead and I see I need a closed circle at 3. And reading the variable first, I see that x is less than or equal to 3. So I want to shade to the left. And notice that this is read that x is in, so x is greater than or equal to -4 and less than 3 means it has to stay in between the two. So this is what an and situation is going to look like, or if you have one inequality with a value on each side, so you have 3 pieces to your inequality. Looking at the last 2 graphing examples, and then we'll move on where you have the graph for you. 5 and 6 would be great ones for you to pause and try. So I'm going to start by marking 4. I'm going to go ahead and say what kind of circle do I need at 4. It looks like I need an open. Reading the variable first, it says x is less than 4, so I shade to the left. Looking at example 6, the last one for the graphing. Again, a good one for you to pause and try. I need both -2 and 0 on my graph. It looks like at -2 I'm going to need an open circle. Reading the variable first, I see that x is less than -2. So I shade to the left. It looks like I need an open circle at 0. I read x is greater than 0, reading the variable first. So I shade to the right. It was an OR situation, and again, notice it does have that same look to it as the OR situation up above did. Moving on to part 2 of the video. Now we are given the graph. I have 4 examples where we're given a graph and we have to write an inequality. So first thing I'm going to do is I'm going to pick a variable. It does not matter which one. Let's say I say x. And if I'm comparing x to this 3, it looks like all my shading is greater than 3. So I'm going to say, and it's an open circle so I know to just use greater than, I'm going to say x is greater than 3. On the second one, it looks like I have to be in between -2 and 5. So again, I pick my variable, and it looks like my variable is bigger than -2, but not equal to, because it's an open circle, and it's smaller than 5, and this time it can be equal. Looking at example 3, 3 and 4, great ones for you to try again. I pick my variable, and it looks like I am shading to the left where it's less than -7, so I'm going to say my x is less than or equal to -7, and again I'm choosing the or equal to because it's closed. And finally the last one, it looks like I can either be less than 13 or I can be greater than 25. So writing 2 separate ones with or in between, I'm going to say x can be less than or equal to 13 because again the hole is closed, or x can be greater than 25, and this time it is not equal to because the hole is not closed. So once again, please make sure that you are able to understand not only how to graph a given inequality, but also how to interpret a graph of an inequality. Bring any questions you have with you to class where you can talk to me about those and we can get those answered for you.